Hi, welcome to my channel. Today's concept is um, I decided to create some videos for the people who are new to Java. I have seen people like I've seen in forums where people are actually um, asking about things like what is a class, what is an object, and there are also people who are interested in Java game development, but they are not familiar with the programming concepts. So I decided to create some videos to explain these concepts like basics that are most useful in application development or game development in Java. So the first video that I'm going to create today is about objects. Let me talk something about objects. Basically, when we talk about objects, some things need to be clarified. Um, you have seen you have seen many videos. You might have seen tutorials. You might have seen you might have read books talking about objects. What is an object? An object is a real world entity. This is a entity that exists in real world. Like for example, buses, public buses. So if you take a public bus or you take any watch, mobile, or any restaurant, hotel, flight, etc. So these are real world objects. They exist in real world. These objects are uh, like since they are existing, they must have some specifications. For example, if I want to buy a mobile, the specifications that I will be looking at will be the battery life, the Wi-Fi, Bluetooth facilities, right? We also have things like dual SIM, single SIM, like that, or 3G, 4G type of network that it supports. So things like that. When you talk about objects like buses, bus is a different object. It has different specifications. For example, it has number of seats, passengers that it can carry. It has it also has like say ticket price. It also has number of stops, number of bus stops, etc., etc., so on. So if you talk about another object like yeah, let's say movie. A movie is an object. It's a real world object. It exists in real world. We watch it and we get entertained. So if a movie exists in real world, what does a movie has? A movie has a name, a protagonist or a main character, and a plot, right, etc., and so on, so on. So we have these objects. These are called objects that exist in real world. Objects like mobiles, bus, movies, hotels, hospitals, cars, etc., etc. So these objects have specifications that make them that make this object worth useful, or you can say worthwhile. Let's say there is a mobile phone, or you can say smartphone that has no touch feature. If there is no touch feature in the smartphone, it will be useless. A touch feature, a smartphone is known for its touch feature. If it is not there, it is useless. You might you might be able to use a keypad phone, but it is not a smartphone. A smartphone requires touch feature because it has gestures. Next, in the same way, buses. If you have a bus, there might be ticket prices and all, so and so. If you don't have number of seats, if there are no seats in the bus, is the bus useful? Absolutely not. That's what I'm saying. These properties or these attributes make the object useful, right? So these attributes make the object useful. This is what we have in real world. In real world, we have objects that exists and they have specifications. But in case of programming, how do we define an object in program? In Java, we have these objects. In Java, we have these objects as data. We represent them as data. In Java, the object is represented as data. For example, I'm taking a movie. If you talk about movie, the movie will have a plot, will have a main character, will have a like release date, will have a review, will have cast, crew, etc., so on, so on, right? So this is what we represent in Java. We denote or we show these data. We show this data through program to represent a movie. This is called as object. Now, if I want to create an application where I can review a movie is released and I can review it. If I want to make an application in such a way, then I have to use these things, right? I will be reviewing the plot. I will be like giving the user option to review the plot, send a small, write a few words, comments, and so on. So I can also like give a movie review, entire movie review, not just a plot review or simply a movie review, like number of stars and so and so. If you want to create an application like that, for example, Rotten Tomatoes or IMDb, so on. If you want to create an application like that, you will be using this data to show this object. Understood? In Java, the object is represented as data. What is the data here? This is the data. So the data belong to this object. So if you're making an application, you will use this data to represent the object. Let's take another object. Let's take an object called pizza. In the pizza, you have like base, the type of base that you're using, thick, thin, crust type, thick crust, thin crust. You also have toppings, etc. So these things are actually part of the pizza. If you make an application where you can order a specific type of pizza, you use this data to represent the object. This is what we use in Java. In Java, when you're writing applications, when you're building applications, you always keep in mind about the data. Okay. Now, if you talk about these applications, if you see here, this application is about ordering a pizza. If I want to order any other food like burger or any other food like chicken tikka masala, so any order, any type of food I want to order, I have a specific type of data that represents this object. I have to use that data. I have to like show that data in my program to represent these objects. Now, let's say we have a collective concept. Let's say I want to create an application where I can order pizza, burger, as well as chicken tikka masala. Now, what do I do here? If I want to create an application like that, what do I do here? I will create quantity. How many quantity of pizza I want, how many quantity of burgers I want, how many chicken tikka masalas I want. Quantity. Then I will see the price of the item, each per quantity. So if you say I want two pizza, each pizza costs 60 rupees something. So that is the price. Then there is an option called coupons. If you have any coupons with you, you can also add the coupons, which will give you discounts. These things, these data can be applicable to the burger as well as to the other options. So every other food options will have this data as a uh, common ground. You can say you have the same type of data for all types of food, right? If you are representing in this way, if you are representing the object in this way, then it is collectively called as food ordering app. Let me explain like once again. In applications, we always represent the object using data. The data is always unique to that object. Burger, the data of the burger is different, the data of the pizza is different, the data about the chicken tikka masala is different. So every other object is different. But if you create an application where you are collectively calling or collectively using the data for all the objects, then it becomes a specific application. It is called food ordering application. Now, let's talk about another one called movie ticket booking or train ticket booking. So, if you're talking about train ticket booking, it has like number of seats, it has availability, vacancies, right? So and so. So, in this case, the data is different. Here, the data is different. Here, the data is different. The collective data, I'm talking about the collective data. Here the collective data is quantity, price, coupons. Here the collective data is number of seats, vacancy, type of berth, etc. So AC, non-AC, so and so. Okay. So this is the data that I'm going to use to represent this object, train ticket booking. Now, if you observe here, we also have the same thing for flight ticket booking. We also have the same thing for movie ticket booking. We also have the same thing for cruise ship. If you want to book a cruise ship, or if you want to book any flight or train or bus, right, or movies. So all kinds of ticket booking applications have or share the same type of data. Now, in this application, you have objects. In the food ordering application, you have objects like pizza, burger, chicken tikka masala, etc. These share similar data, whereas the applications itself, the application itself, like ticket booking, train ticket booking, flight ticket booking, movie ticket booking, bus ticket booking, etc., these also share data, right? So what I'm trying to say here is, if you talk about objects, object is a real world entity. It exists in real world. If you want to book a train ticket, you go to the platform and you book a train. If you want to book a flight ticket, you go to the airport. If you want to book a movie ticket, you go to the movie theater. If you want to book a bus ticket, you go to the nearest bus station. So each and every type of object exists in real world. This is what I'm trying to say. These data that I'm using here is also applicable to flights, applicable to movies. So these are also considered as objects. These are also considered as objects in programming, because in real world they exist. So we are showing that real world functionality in our program through data. So in programming, these applications are considered as objects. Now, collectively, these applications are called as ticket booking applications, ticket booking apps. So what is a ticket booking app? Ticket booking app is the class. Ticket booking app is the class. Inside the ticket booking app, we have number of seats, availability, so and so. These data members or these data can be used for trains, flights, movies, etc. So what we say is, if these are real world entities and we are representing them in the class or in the program, then these are considered as objects. These objects, flight, movie ticket, train ticket, etc., these objects are classified as ticket booking apps. So a class is a collection of objects. A class is a collection of objects. What does it mean? It means it has objects. For example, here I said ticket booking apps. So ticket booking apps is a class. Ticket booking apps is a class. It has objects like train ticket, flight ticket, and movie ticket. If you talk about food ordering apps, for example, we have food ordering app, we have bakery ordering app, we have canteen ordering app, or we have hotel ordering app. If you want to buy book a like special dish or something, you can use these apps to book food. For example, in India we have Swiggy or Zomato. These apps are also food ordering apps. So what these ordering apps are doing, these food ordering apps are actually real world entities. They exist in real world. Zomato is a company, Swiggy is a company. The same way, if you have a bakery near your house, they also are existing in real world. They are also having their own application. So these bakeries, food ordering apps are all, these bakeries companies are all called as food ordering application companies. This is the class. These are the objects. Understood? So this is what we called as class food ordering app. Inside the class food ordering app, we have the members, the data that represents this object. Why? Because collectively all food ordering because collectively all food ordering applications will use these data. Understood? Every food ordering application will use quantity, price, coupons, etc. So it doesn't matter whether you are using a bakery or a hotel or a canteen or a mess, it doesn't matter. It will be using this data. So if this is a class, the class contains the data that is used in the object. The app is the object. The application is the object, because the application represents something that exists in real world. So this is how we show objects in Java. The object is the front end. The class is the back end. The class contains the data. The objects use the data through getters and setters. This is where we are using getters and setters. In my program, if I create an application, the application front end will use get set, get name, set name, get company name, get set company name, get price, get discount. Those getters and setters are basically the things that are used by the application. For example, let's say I made an application called food ordering application, or let's say I made an application called bakery application. So I created a bakery application. I wrote the class. I gave all these functions, variables and everything. I wrote the class. Nice. The application is done. Now I want to create a hotel application or hotel food ordering application. Same thing. Just the front end differs. In the bakery, the front end application will have cakes, pastries, sweets, desserts. In the hotel, you have food. You have spicy food, non-spicy food, normal food, continental food, etc. All of these are also using the same properties. So instead of writing the same program again and again, I can import this code and build this application. I can import the backend and build the front end and directly use the application, directly create the application using this code. This is what we are doing in programs. This is called as software development. We don't write the programs. As a programmer, you shouldn't write the programs multiple times. Don't copy and paste. Don't write the programs multiple times. You might change some things. For example, in the bakery, let's say the bakery application used some kind of functionality that is not needed for the hotel management or the hotel application. Well, that is where private and public comes. If you talk about public and private members, this is where it is. Those things that you don't want, just make it as private, or those you want, just create as public. And if you want to change the behavior, overriding and overloading exists, right? So this is the things. If you want to inherit a previous class that is already written, an application that is already written, we use inheritance, extends, implements, etc. If you want to change anything, we use polymorphism, overloading and overriding techniques to change the behavior. If you want to let's say I want to restrict the data from one application to another application, we use encapsulations, techniques called encapsulation, private, public, protected, like so and so. Okay, if you want to use a specific type of data, a specific type of functionality for both applications, similar applications, then we use abstraction. As I said, abstraction because it is similar for both applications. If you talk about like bakery as well as canteen, both have similar functionalities. So if you want to import the already written functionality, just use inheritance, extends. If you want to write it, then use abstraction. You have the similar functionality, but you should write the body of the function. Like for example, you have a payment gateway. Payment gateway is already written here. Just import it and change the data. That's it. Or if you want to write a new payment gateway, you want to add more vendors, then you should write it on your own. You should like override on your own. Right? This is what we call as class and objects. This is the functionality of OOPS concepts, object-oriented programming structure. The object-oriented programming structure is not just a structure of the program. It is the core of the application. The applications that we are building, the games that we are writing are built on these principles. What is the principle? The thing that you see in real world is represented as data. The data exists in class in the backend. The class contains the data in the backend. In the front end, either you are using swings or you are using JavaFX or you are using servlets and JSP or you are using HTML. You can use anything in the front end. In the back end, you will be having the code. So from the back end, to get it to the front end, we use setters and getters. This is the concept of writing programs in Java. Java is not just a application or a programming language. It is a tool to make applications, apps. In the apps, most of the people who understood, who learn these concepts, they read this concept about objects and classes. They say that object is a real world entity and class is a collection of objects. Well, it doesn't make sense. If class is a collection of objects, then why are you writing program in class? You should write objects in class, right? This is the concept. It doesn't make sense because this is what it is. What you read is just things that are shown in the real world. In case of, or you can say in reference to programming, this is what it is. Object in programming is a collection of data. The data is in the class. This is why we have data members and member functions in the class. This is why we write the program in the class, because the class has the data that is used in the object or that is used to show the object. Either we use it, either we create it, or either we control it. That means control the object. For example, we wrote a program to control a smartphone. Let's say you made a game. In the game, you have a joystick. That joystick will control your character. If you move the joystick, the character will move in the game. So you are controlling an object using your program. The second way, let's say you have data that you want to show. You have like high scores. You want to show the high scores. So you have the data in the backend. Just get the data and show it. So now you wrote a code. Now the code will only show the data about the object. It is not controlling it is showing the data. So this is how it is. When you're writing programming, you must always remember that class contains data. Objects are represented as data in Java programming. The object that we use when you say new something, it is just a reference. It is not an object. Let me show you. If I say an object called pen obj equal to new pen. When I say new pen, I am not saying that it is an object. I am saying I am creating a new reference to this object. Now this obj is an object reference. If you want to print this, if you just simply print this system.out.println and just print obj, you will get an object reference like @ some 0a4f something like this. This is called as object reference. It is not the object. It is a reference. What is an object? An object looks like this. Java dot lang dot object @ something 0a4f. This is an object. Okay, this is an object. This is a reference. What does it mean? It means when you create a code like this, when you say new something, that is creating an object in your memory, and then it will assign that object reference to this variable. This is a variable. Okay. Now, when I say new pen, It means it is existing in real world. So obviously it will have the data. What is the data? The data, for example, I said system.out.println. I said uh, object dot company name. So where is this company name coming from? It is coming from the class. Okay, this is why we say get company name. Now we get the data from the class. When I say the same thing, but instead of get company name, I will say get price. I'll get the price from the class. Understood? So this is what we call as getters and setters. The class called pen have all the data members and the member functions are existing in the class. We create an object with the data and now we call the data. Now, how do you create an object with the data? Well, that is where the constructors comes in. You know the constructors concept. Constructors assign the data like this. Let's say company name Reynolds. Okay, so we created an object. We made an object using the data. So as soon as the object is created, the data is assigned. And now when you say company name, you get Reynolds. And if the price is, let's say 10 rupees. So when I say get price, I'll get 10 rupees. So this is what we call as class and objects. Class contains the data. Objects use the data. Understood? And we show the data from the object using a reference. This is the object. This is the reference. Now, if I want to show all this in a program, how do I show it? Let me show you. First of all, let me create a project called Java Concepts. In this project, I'm going to create a class. Okay. Let's say OPS, Oops Concepts. This is a package name. Fine. Let's create a class. The class name here is bus. I'm saying bus. So whenever I say bus, the bus will have the data. If I want to create an object, I will create an object and I will pass the data from that object, which will come here and it will assign to the class. So there is a bus class. Now, if you talk about buses, what do you do mostly? We see the number of seats, int seats. We have int vacancies, how many seats vacant. We have let's say int number of stops, num stops, how many stops the bus will go through. So these three are integers. Now, how do I assign the data? Well, I have a constructor for that. Int seats, int vacancies, and int num stops. Okay, so this is where I assign the data. This seats equal to seats, this dot vacancies equal to vacancies, and this dot num stops equal to num stops. Okay, now once I assign the data, I have to get it back. So why do I get it back? Because the data is actually private. Why? So that no one can access it unnecessarily. This is called encapsulation. We are encapsulating the data so that nobody can access it unnecessarily into any other application. So now I'm going to create a code. Public int get number of seats. So number of seats will be given as this. So whenever I say print get number of seats, I'll get this. The same way, int get vacancies. How many vacancies we have? How many seats still available? So I say vacant seats are like this. Then I have public int get number of stops. How many number of stops do we have? So num stops. This is what we show. Now this is called a class. The class contains the data that will be used, shown or used in an object. Okay, an object is a real world entity. An object is a real world entity. These objects are grouped together as a class because they are classified as something. So if I am talking about buses, all types of buses have these variables. This is why we are writing all of this in a class. Now, once you have the data in the class, the next part is to create objects. So let's create an object. I'm making an object here. A class called main class will create objects. Let's create a main function. In this, I'm creating bus b equal to new bus. So as soon as I said new bus, there will be data. The program asks me to enter the data. So I have 10 seats. I have 3 available and number of stops is 5. Okay. Now, if I try to print B, this is the bus. This is an object. But if I try to print the object, see what we get. What did we get? Bus. This is the bus at the rate of this. This is the object reference. So this is what I'm saying. The object reference is stored in the variable. The object is created and the object reference is stored in the variable. This reference will be used to call the data. Get number of seats, system out b dot get number of vacancies, and system out b dot get number of stops. Now I am using a front end called console. This is the console front end. If I want to create a UI, I can use Swings or AWT and show the same thing in the UI. That is the front end. Or I can also send this data from the server to HTML and show the data in the HTML page. Understood? So this is what we call as front end. The front end have the data shown as the front end has the objects. The front end has the objects and the object is showing the data. The data is coming from the back end here. Okay, the data is stored in the class backend and the object is in the front end. So whenever you open Amazon, Flipkart, Walmart or any other shopping application, Myntra or Shopify, etc., etc. So when you're opening these applications, you see the data of the object. The data of the object will be shown in the front end. Where is the data coming from? The data is coming from the back end. From here, from the class. Now, in this case, I gave the data like this. But in applications, we don't give this. We don't write it like here. We simply say bus b equal to new bus. And we give a bus number. Let's say 1. Immediately, this number will be tracked from the database, and the data will be collected into this class. Once the class have the data, then the front end can able to call the data like this. So in the database you have a table where you have bus number, you have seats, number of seats, you have vacancies, and you have number of stops. So how many stops there are for per each bus. So if the bus 1 has, let's say, 100 seats, bus 2 has, let's say, 50 seats, and bus 3, let's say, it has a little bit in between, 70 seats. Now whenever I say bus 1, automatically the class will get this data and it will populate these data members. The class will look up this table, it will find out the number, then it will automatically retrieve the data from the database. Once the data is given to the class here, it will automatically fill out the number of seats, vacancies, and number of stops. And then whenever in the front end I say number of seats, for the bus 1 it will show 100. This is how an application is built. An application uses the objects and the object data to build and to create. For example, I have an application, let's say in hospital management. We have an application called hospital management. In the hospital management, we have doctor data, doctor's info, we have patient info, and we have bed info. How many beds are vacant, how many beds are available, like you can also book a bed on moment's notice, or you can also apply for surgery, right? You can also take appointments. All of this are actually related, all of this are actually like you call this as related to representing the hospital object, right? All of this data represents a hospital. So when you talk about hospital, hospital is an object. The data that is shown here is representing hospital. So in Java, we create a class called hospital and we represent this data. We represent the data. For example, I create a list of doctors. I create a list of patients. Doctor and patient. I create a list of beds. How many beds we have. Or if you want to create a specific list, for example, say map of type of bed, or you can say room type, comma bed. Okay, so you can also create a list of map like this. So this is what we have in the class. The class contains all the data that is used by the object. So in the real world we have object. Now in the application, when I create an application here, let's say the client app, class client, I will create the main function here, and in the main function I will say hospital, hospital, hospital h equal to, I said new hospital. Immediately what will happen is it will create lists like this. Immediately it will take the lists and it will create the lists. As soon as I said hospital and I passed the data, let's say hospital number, some number like 1024. So as soon as I said hospital number 1024, it will immediately go to the database, find the hospital details and fill these details, fill the data and store them in the class. Now when I say h.get doctors, h.get doctor info, immediately it will show me all the doctors available in the hospital. If I say h.get patient info, immediately it will show all the patient's info. This is how we create applications. This is what we call as the backend. The backend contains the data and the front end contains the view of the data. This is where you show the data. We are not creating the data like this. We are not making a view like this. We are actually making a view using swings or JSP or HTML, so and so. This is what we use in applications. Games are also similar to applications because games are also apps. In applications like mobile applications or any other real world applications like hospital management or hotel management, these applications have a different kind of data than games. The game data is similar to these like hospitals and everything, but they are completely a different functionality. The game data has a different functionality, the hospital data has a different functionality. Understood? So when you talk about objects in real world exists. That is why they are called objects. These are a real world entities. These exist in real world. We show these objects in Java as data. We show them as data. When you show multiple objects as data, some objects share similar data. So we club them, we group them into a class. Understood? When you have similar objects that have similar data, we group them into a class. So what do we say? The class has all the data that the object wants. Just call the class and it will give the data. Simple. Okay. This is what we learn in Java. This is called as class and objects. It is a very it's a very depth concept. It is not that easy to explain. It is not like a simple way to say object is a real world entity and class is a collection of objects. This is why we write code in class. It doesn't make sense. Whereas if you explain this way, that objects are real world, objects in real world are represented as data in program. That data is stored in the class. Now you know why you're writing programs in class. Because you have to handle the data. Understood? This is what I want to clarify. This is for the first video. Class and objects. The next video, I'm going to show you how we do inheritance, how we are going to reuse the previously written program into our new application. If I have an application that is already written, that is already made, is already working, how do I use that program into my new application and create it from scratch? Instead of writing it from scratch, how do I make it using the previous program? That I'll show in the next video. Thank you for watching.